change is so fast. Because when you design and build a data center, you're talking about 2 years, 3 years time. And you build that asset to be operated over 40, 50 years. So when the rate of technology, innovation, rate of change is so fast, you don't know what's going to come in 3 years. You don't know what's going to come for 5 years. So you build for what? What flexibility, what possibly future is going to demand from that data center is not very well known. If you see, specifically talking about data center, 6-7 kilowatt racks few years ago, 80, 90 already, 150, God knows where is it going to end. So how do you design a data center, build and operate for next 40 years when you don't know what's going to happen? And it's not a structure or it's not an MEP fit out, which is very easy for you to change. It takes a lot of time, it takes a lot of cost for you to realign. Let's say you want to convert a low or medium density data center to high density tomorrow, it's not easy. And once you commission a data center, when part of it is already running infrastructure of other customers, you cannot modify some floors and make it, for example, the structure load capacity is 1500 kg per square meter a few years ago. We are already at 2.5. We are designing data centers which are going close to 3000. So when right from the core and shell, the building structure things are going to change, how do you do that? So there has to be a lot of agility and flexibility that you have to bring in design. When you design for data center AI, higher workload, higher density, the capex cost also is very high. Now, because of the market the way it is, the revenues are compressed. There is more competition, more intense competition. So in the market, you have a lot of pressure to survive and grow, to earn business. On the other side, the cost, because of various reasons, we know the world has war zones, the world has trade wars, tariff wars. So since COVID, we have seen the pricing considerably has gone up. Then there was a time when it stabilized. But another thing is your customers want what you built in 3 years earlier, your customers want you to build in 2 years today and then 1 year. So it is a very, very difficult triangle to handle. On one side, you have to do things fast. And as a fundamental rule, when you expedite, your cost goes up. Your costs actually are going up, but customer wants to pay you less. You don't know what you're going to build for. So it's not an easy maze. And therefore, the expertise, the knowledge of that field is very, very important.
Oh, that's very beautifully laid out, the challenges in terms of volatility of the requirements by itself, and then the changing requirements, how do you accommodate, as well as the cost being more imperative. Thank you so much. Sunny, over to you.
Sure. So, hi everybody, I'm Sunny Gupta. I'm a Senior Director of Technology at JioHotstar. Most of you all are hopefully enjoying the IPLs during the evenings. So I come from the application development side of the world, right? I have not spent time designing data centers, so I just want to give that disclaimer, right? But with the advent of AI and the kind of opportunities that arise for all of these apps, in fact, not just a streaming app, but let's say even an app like Flipkart, an app like Amazon, the kind of traffics that we're kind of seeing these days, right? I think it's also onto, the challenges of going from 6 to 7 gigawatts to kilowatts to 680 kilowatts. I think that's also in part because of the way we design our applications, right? So some very interesting ways of looking at it are starting to emerge, and it is our responsibility also as application developers to kind of see what part can potentially be handled on edge networks, what part can actually needs to be rerouted to central networks. There are going to be areas where we can optimize and extract out needs which can actually be shared, and so you can probably bring those closer to the edge and thereby reduce the dependency and on this central networks themselves. Again, it is not as predictable as we would want it to be, and things are changing continuously. So I think from an application development side and angle of view, I would say it is also going to be a responsibility from our end to make sure the loads remain sane. Yeah.
Hi, very good afternoon to one and all.
Well said.
Myself Karthikeyan, I head the MEP design at L&T. See, from the morning it's very evident that the next driving factor in the data center is the AI-driven servers. So it's going to grow in threefold. So it's in the tune of 3 gigawatts. So the major challenges, what I see on the three critical factors in the data center is the power, the network, and as well as on the cooling. See, power, I think the utility companies across the states has a very big responsibility in ramping up the capacity and ensure the power is reliable, which is most important in any data center. Actually, this helps us to reduce the on-site deployment of backups, which in turn will reduce on the carbon footprints and as well as on the other sources. And on the network side, the increase in bandwidth is required because all these data centers, all these AI-driven servers are going to require more data. And on the cooling, as a mechanical design engineer, we have a big responsibility to strike a balance on how efficiently we design the cooling system to catch up these power guzzlers. So we need to have a right balance of using the air cool along with the water cool. Liquid cool is the only solution towards this AI-driven servers, but we need to see how effectively we use it. So these are three parameters where I feel we have a bigger responsibility on the technical front. And on the construction front, what I see is most of our customers whom we get, they want the data center to be designed and built and handed over in 18 months to 24 months. So this is a huge task for the designers as well as the general contractors. So here, when in the day one of the design, when the project is given, the design has to be in place so that the execution can happen on the day one where it goes, so that the sufficient time is given for the testing and commissioning. So these are the three areas I feel that there's a gap which needs to be taken care. The way forward, what I see with this growth.
Thank you, Karthikeyan and Sunny, and for bringing out a very different application perspective on how it could influence the design of the data center, and Karthikeyan for touching upon cooling, power, infrastructure, construction aspects. And that dovetails beautifully into my next question to you, Mr. Sandeep. If you could touch upon, with the rising demand of power densities due to the AI workloads, how are you envisioning the future of cooling and power strategies in India's hyperscale data centers? And are we actually equipped to handle the surge sustainably, was the question.
I think you brought up few streams in it. One, you spoke about importance of providing cooling adequately. Second is providing the power. And the third is sustainability. So as far as cooling is concerned, we all know since morning everybody must have heard there is liquid cooling, there is direct to chip cooling, there is back of the rack cooling. So these are all newer age cooling technologies primarily designed to increase cooling efficiency, cooling capability, which means when you have higher workload of AI, first of all the device requires more power and then they throw out more heat. So you need again more power to cool them. So cooling efficiency becomes very, very important in the data center for AI. Each of these three or a combination of them could be a right strategy. There is no one shirt that fits all. It all depends upon what your data center is supposed to cater to, which customer, what workloads, what applications, etc. like you said. So it could be a combination of liquid cooling or direct to chip or back of the rack. Each of these have pros and cons. There is no one that is absolutely good on all parameters and the other one which is not so good. So, so that's one part. The second is availability of power. If you look at one, and nobody builds data center now as a building. we came to campus, now we are talking about parks. Even campuses will be story of past. We are talking about data center parks now. So one data center park will have electrical load like any city actually. So much power has to be made available, which means there is a tremendous space for private power producers. Even data center players are, you heard the discussions since morning. You also need captive power, and there is a regulatory part when you talk about captive power or open access. You also need a lot of support from government, from regulatory compliance point of view to enable that. So that has a direct connection of sustainability, because how data centers are having a large potential to harm the environment, and which we need to mitigate therefore, is one, tremendous amount of power is consumed. So if you get green power, as much better green power, as much lesser fossil fuel power, that much you are impacting lesser to the earth. The second part is heat. As much less heat you create, that much less heat you need to extract. So again, the power efficiency. The third is, when you extract heat, you are going to throw it in the environment. So again, that's an impact. And fourth is vibration in the nearby vicinity of DGs and chillers. These are monsters. When you fire the DGs, and if you have a residential area nearby, it could be a big nuisance to them. So you obviously get acoustics and enclosures and all that. And the suite of DGs. If you, in cities where we talk about edge data centers, where you may not have 24/7, 365 days continuity of power, which means you need to run them on DGs. And there is then the problem of pollution, right? So from all these angles, water consumption is another thing. Wherever possible, we have to use air-cooled chillers and prefer them over water-cooled chillers. So these are different streams in which we need to bring down the impact of data centers to environment.
Thank you for the extreme insights and for the wide spectrum that you have covered between cooling, power, and most importantly sustainability, and emphasizing the need of green power and all of its impact on the ecosystem. Just switching gears, and Sunny, to you, the question is, on a streaming platform, we handle very massive real-time data streams, and how is AI impacting the infrastructure, especially when we require extreme ultra-low latency and high availability?
So this is again, a very interesting set of challenges, and again, not just for a streaming platform, but anybody who deals with spiky traffic is always going to face these challenges, right? Where you have to prepare for, like, let's say, a few hours of peak loads, and you can't just provision for the peak load throughout the entire, let's say, year or so, right? And so you use AI to combat this as well, right? So the kind of issues that platforms like this then eventually face is, you want to obviously optimize for the cost. You can't be operating at your peak costs at all times. How do you then go about doing it? Thankfully, previously, while you would need a lot of analysis, you would throw a lot of money in getting all of these analysis and research is done. Thankfully, AI is also now allowing us to look at past patterns, look at the fact that, hey, you know what, this is a match between, let's say, team A and team B, and XYZ cricketer is just about to come. Previously, we have seen that there is a 35% increment every time. So there are going to be cases, and we've seen cases where something that a human might miss are things that AI catches hold of, and those things allow you to then say, all right, we are going to do some pre-computes to decide what our infra onboarding ramp has to look like, and then provision that, have contracts with your providers, your data center, your CDN providers in place, so that there is some headroom available depending upon the kind of things you predict. And then even after that, sometimes you may see situations where you probably did not predict the exact number, right? So then how do you then make use of these adaptive bit rates? And this time you have to now rely on the client's side AI capabilities and say, hey, you know what, looks like the servers are currently probably for a short time overloaded or maybe provisioning. And so during that time, you would adaptively reduce the bit rate, right? So that you're able to now able to at least serve all the customers, and for a brief bit you could potentially reduce the quality for a bit, but then again you're not compromising on availability. And so again, these are some challenges we do.
Yeah, very interesting to understand how you're using AI to predict, first of all, the surges in the traffic, and then, as you said, adaptively changing the quality or the bitrate to handle these volume surges. Thanks, Sunny. Shifting gears again to Mr. Karthikeyan, like as a leader in MEP design, how are you preparing for the infrastructure projects to handle demands from the AI-driven workloads, again, specifically concerning to the thermal and energy efficiency, thermal management and energy efficiency?
See, we MEP design engineers have a very big role in designing an efficient system. Especially in the data center, if you see, there are three areas we are very careful in designing at the early stage. So especially the data center hall, the DG rooms, and the chiller. So these are the areas where the equipments are highly populated, and we need to really carefully handle the heat spots and how the heat air movement is there. So we do a advanced CFD analysis to ensure that to understand how the airflow is happening and where the hotspots are happening, and we clearly map the thermal mapping and see that a cooling system which we produce and as well as the ventilation system which we deploy takes care of all these issues on the thermal thing. And as we all know, the AI-driven servers, the heat is going to be huge and cooling is a big challenge. And it is necessary to dissipate or cool the heat which is at the source side. So the current technology what we have is DCLC with a combination of rear door heat exchangers, and we have direct liquid cooling, and we have other systems with immersed liquid cooling. So it is the process where it goes. So from the 20 to 30 kilowatt racks, we can manage with rear door heat exchangers, and when it goes up to 100 kilowatt, we need to go for the immersed liquid cooling. So there we carefully handle this. On the energy efficiency, if you see, when we have a data center, so we need to have a smart IMEMS system in place to monitor and control all the components of the complete data center which is in function. So we have a high-level integration with the IBMS, with the DCMI, so where the complete data center is completely monitored and controlled on a predictive analysis mode, and we deploy digital twin in the system to see that the system is always reliable and we have the predictive analysis in place. So these are the two major things which we take care. And on the energy efficiency design, all the components we are very careful in selecting it, right from the transformer, the right type transformer what we use, we ensure that it meets the ECBC losses to see that 99% efficiency is taken care, and the UPS what we deploy, which is the most important component in this data center, we see that it is having the efficiency of 97-98%, and as well as other factors such as deploying the VFDs to see the energy efficiency is taken care across all the HVAC loads, and then mitigating the harmonics. So deploying the active harmonic filters in place to see that the harmonics are mitigated at the source site itself. So these are the other aspects which we take care to ensure that the energy efficiency take care. So that is how we handle it.
Yeah, thank you for such valuable insights, right from touching upon how heat dissemination happens, plus the energy efficiency, including digital twin and the selection of every component. Again, let's kind of look into a very different dimension now. So to you, Sandeep, how do you think AI is transforming the data center operational landscape? How are we looking at AI transforming the future of predictive maintenance and so on, and how is this entire landscape evolving right now?
Sure. As you very rightly mentioned in your question itself, the mindset, the objective of operations is changing from conventional or root cause analysis, fault finding and repair to predictive. That is where AI has tremendous potential, and we have started utilizing AI capabilities in various organizations. However, we possibly are still scratching surface considering the opportunity, the space available, and the capability of AI tools. But at the same time, just to give you some example, we are talking about cooling here. Every possible optimization, small possible optimization in cooling becomes very vital. And wherever AI can reduce human dependency, can, like you said, eliminate human errors, bring up opportunities which could be possibly in the blind spot for human eyes, all those are thrown up by AI. And any possible savings in or enhancement in efficiency of cooling is a tremendous gain. Also money saved as well as sustainability. So that's one space where AI is being adopted. The second is, if I give you an example of one data center, let's say has 5,000 camera, it is humanly impossible for anybody to sit and try and understand what's happening where. So you can feed parameters, you can feed deviation parameters, normalcy parameters, and you directly get an information about what's not going right where. And you only address that particular thing rather than having to sit at a monitor and monitor all 5,000 kind of frames. These are just very basic, some simple examples. The actual potential is much beyond, like I said, but for everybody to understand where can AI in operation find application, these are some of the examples.
Thank you again, Sandeep, for touching upon that, on how AI is actually helping eliminate some of the human errors, reduce cost, as well as handle scale, which probably is not possible from a human. Over to you, Sunny. With increasing, let's touch upon the edge computing a bit. So with the increasing AI adoption, edge computing, of course, is becoming very crucial, right? So how do you think we should be balancing edge deployments versus centralized cloud in delivering very seamless user experiences?
So again, very apt example here, again, because of the industry we operate in. When the entire nation is tuning into the content that you're serving, centralized servers are, it would be close to impossible to be able to do that. I mean, it's possible, but then the costs are going to be insane, right? So our dependence on edge networks is baked into the high level design. Like if you were to come up with a system, you would say, hey, why don't you offload some amount of the streaming aspect of things to CDNs, right? Now, do you require AI today to be able to stream data to a CDN and then a CDN to then send it over to a user? Not really, right? Even before AI came into the picture, people were able to do this. But with the advent of AI, you now have opportunities to predict. If you look at a war room, and if you look at the nationwide map, and you look at the kind of traffic patterns you're seeing, you end up choking a lot of paths as well. Sometimes, let's say it's a Gujarat match and there's a area where network is not that great. If your preferred route or your preferred CDN provider is not around, you have to create multi-CDN, multi-cloud strategies, right? And then make use of AI. If you are detecting that this place, this route that we are currently using to serve users in this area is getting overloaded or is nearing capacity, right? You would want to then predict what other routes. Maybe you can ask them to get data from a nearby region, right? These things, again, if you look at a nationwide spread of people, and if you try to get this done, previously it was done using people, right? I think there is a future in which AI can seamlessly be doing this. In fact, avoid people even reaching 90% threshold, and you could just say, hey, you know what, this is reaching near 70-75%, why don't we start rerouting traffic to a different thing? It is better for somebody to, let's say, look at a match half a second later than look at it in a broken format. So I think these are some interesting areas where development is still happening across the industry for multiple things. But yeah, this is where I think AI is going to help us.
Very interesting to hear from you on how AI could actually detect network clogs or traffic clogs, and then automatically, especially with all of this agenting coming into picture, I think we could have it automatically redirect traffic. Yeah, interesting space to be in. Again, switching gears to Karthik, to you. So India is a very unique landscape, right? Like in terms of the grid reliability as well as water availability. Now, how are we navigating these challenges while still deploying or thinking about hyperscale AI deployments, which we heard 80 times more is the requirement, 100 times more. So how are we trying to navigate these challenges?
Yeah, on the power reliability, as I told earlier, there's a huge challenge. But with the demand with the supply voltage up to 66 kV is not reliable across any states in the country. So especially on a voltage level at 110 kV, 220 and 400, to major extent it's reliable. But then what I foresee is that we need to have a self-sufficient data center to take care of the power as much as possible with various schemes. Like you should have a power purchase agreement with the utility companies. So that is one way I see. Another thing is that to overcome the other issues, we should have the battery energy storage system is one technology which is picking up where there is a huge demand load. So that is one thing which I think there's a very big scope, and it also helps in the energy efficiency also, because during off-peak season you can store and then you can utilize the power on the peak time. So with that we can have a better energy efficiency. And on the water side, as we all talked about, liquid cooling is the only way to handle the rise in power load. So we need to strike a balance between the usage of air-cooled and water-cooled system with the right mix of 80-20 or 70-30 to see that it is all utilized properly. And to overcome the water scarcity, we need to see as much as possible the water which is utilized in the premises is recycled and reused in all aspects, to see that we should strive to more towards net zero water. So ultimately, most of the panelists in the previous sessions, they told that by the next 3 to 5 years, we should target to go on net zero water, power and carbon. So I think that way forward, if you see, with all these things, if we implement, I think it can be handled efficiently.
Yeah, thank you, Karthikeyan. And in the interest of time, I'll be kind of making the closing remarks and opening it up for audience Q&A, and probably have only 1 or 2 questions. So just closing remarks, like, today's discussion from all of our esteemed panelists has brought out one thing very clearly, like AI is not only pushing the boundaries of digital infrastructure, but it is redefining the very architecture by itself, right? So right from cooling innovations to power strategies to edge deployments and sustainably doing this, we are certainly in the cusp of a new era of engineering. And all what we need to do is not only define for scale, but as I was touching upon in my opening remarks, do it very responsibly, sustainably, securely, and in a resilient manner. So with that, we'll take up 2 questions from the audience.
Hi, can you hear me? My question is more on the application of AI in the design, specifically to Karthik. Do you use during your pre-build, like when you design any data center or associated components, do you apply AI in terms of validating your basically like your design build?
Validating the design,
yeah,
what we give for the data center.
Yeah.
Yeah, one of the application which I told is the CFD analysis. What we do, it is more like an more like an AI-driven design tool. And then on the design, we have this BIM. We have implemented in a big way, where we can design the data center effectively using the BIM platform. These are two major things which we use. And then there are certain design applications in-house we have developed to automate the design. So these are 3 things we see.
Thank you so much for the enlightening session. A big round of applause for all our speakers.